Okay, we're going to talk about hyperbolic functions. Actually, hyperbolic trig functions. Hyperbolic functions. We're going to define the following functions. We're going to define the sinh of x, or the sinh of u. Let's call it the sinh of x. Their h means hyperbolic sine of x. It's another way of saying it. Hyperbolic sine of x. And this is defined to be e to the x minus e to the minus x over 2. And we define the hyperbolic cosine of x, also known as cos of x, as e to the x plus e to the negative x over 2. And we define the hyperbolic tangent of x, just like in ordinary tangent of x, it's sine over cosine. That is, it's cos of x divided by, the sinh of x divided by the cos of x. And if you take this function and you divide it by that function, you get the 2's will cancel. You get e to the x minus e to the minus x, to e to the x plus e to the minus x. The cosecant hyperbolic of x is 1 over the sinh of x. Just like cosecant of x equals 1 over sine of x. That is, you get 2 over e to the x minus e to the minus x. I just took the reciprocal of sinh of x. The secant hyperbolic of x is 1 over the hyperbolic 1 over the cos of x. 1 over cos of x. One divided by the hyperbolic cosine of x, which is 2 over e to the x plus e to the minus x. And the last one we'll put up here, the hyperbolic cotangent of x. Well, this is the reciprocal of hyperbolic tangent of x. That is, it's the reciprocal of this. It's e to the x plus e to the minus x over e to the x minus e to the minus x. Okay, now you can get away with just knowing these two and knowing that the hyperbolic tangent of x is the sinh of x over the cos of x. And you get that. And that their hyperbolic cosecant of x is just the reciprocal of sinh of x. Don't really have to do any dividing there like we did with hyperbolic tangent. Just flip over, we take the reciprocal of sinh of x. Secant hyperbolic, flip over the cos of x. Cotangent hyperbolic of x, well, if you know what the tangent of x is, flip it over, you'll get the hyperbolic cotangent of x. Let's talk about the derivative. Okay, yeah, let's talk about the derivative of these. Let us talk about the derivatives. Using the definitions I just gave you for sinh and cos, etc., we can show that the derivative of hyperbolic sinh of u is just cos of u times the derivative of u. Recall the derivative of sine of u is cosine of u times the derivative of u. Here it's going to be slightly different, not much. The derivative of the cos of u, let me change the line above. I'm taking derivative of the and we sinh of u. This is, well, the derivative of cosine of u is negative sine of u times u prime. So you might think the derivative of cos of u will be negative sinh of u times u prime. But it isn't. No minus sign. No minus sign. The derivative of hyperbolic tangent of u, this is hyperbolic secant squared of u times u prime. And the question is there a minus sign? And no, there isn't. The derivative of hyperbolic secant of u, this is going to have a minus, I bet. Let me think about that. Yeah. Now, if you just think secant of u, the derivative of secant of u is secant of u times the tangent of u times du. Times u prime. I meant to say du dx. Well, these are hyperbolic. And you get a minus in front. It's a pain in the neck, but they're not matching up exactly with the trig functions. They're very close. You'll just be off by a minus sign, but you have to say h each time. They give you h, the derivatives will always have the h. The derivative of hyperbolic cosecant of u this is going to be, this one, here I'll have the minus. It's minus hyperbolic cosecant of u times hyperbolic cotangent of u times u prime. And lastly, the derivative of hyperbolic cotant of u, this will be negative cosecant squared hyperbolic of u times u prime. Okay. Now, if you have derivative formulas, you have integral formulas. The integral of this du is equal to that. The integral of cos of u du is equal to the sinh of u plus c. Every time you take an integral, plus c, unless it's a definite integral. The integral of sinh of u du, integral of sinh of u du is equal to cos of u, plus a constant. The integral of this du is that. You only have to remember either what's in red or what's in the black color. You don't have to remember both of them. In fact, for each pair, here's the pair right here, you just need to remember one or the other. If you know one, you should be able to get the other for free. If you know one of these two, you get the other one for free. You have this pair here, and now let's work on the one right above the red marker. The integral, I'll pass the minus to the other side. I'll multiply both sides by minus 1. So the integral of secant of u times the tangent, hyperbolic tangent of u du, this is equal to hyperbolic secant of u plus c. This is being multiplied. Secant hyperbolic u times tangent hyperbolic u du. That equals secant hyperbolic u plus c. Okay. Multiply. Oh, I forgot to put the minus on the other side. I put this minus on the other side. The integral of that, integral of hyperbolic cosecant of u times hyperbolic cotangent of u times du is equal to negative this mess here. Cosecant hyperbolic of u plus a constant. The last one. Bring the minus to the other side. The integral of cosecant squared hyperbolic of u times du, well, that equals hyperbolic cotangent of u plus a constant minus negative cotangent hyperbolic of u plus c. If you know one of, in each of the 6 pairs, if you know one of them, you can have the other one for free. There's better things to do than go home and memorize 12 formulas when you only need 6. There's much better things to do. Do more math problems, study other subjects, go to the movies, whatever you prefer. But don't memorize all 12 of them. I never did. Okay. Now, there are some identities that you should know. For example, cos squared of x. It's probably going to be minus this time. Minus the sinh squared of x. This is 1. That is e to the x plus e to the minus x over 2 minus e to the x minus e to the minus x over 2. Oh, I forgot to square it. Sorry. This is going to equal 1. When you square the bottom, you get 4. When you square the numerator, you get e to the 2x plus 2e plus 2 plus 2 plus e to the minus 2x minus. Now we have to square that. When you square the bottom, you get that. The numerator will be e to the 2x minus 2 plus e to the minus 2x. Since everything's over 4, I can keep it the same. E to the 2x minus e to the 2x, bye-bye, it's 0. Positive e to the minus 2x minus the same thing. Positive e to the minus 2x, that is 0. Positive 2 minus negative 2 is 4. 2 minus 2 is 0. But we don't have 2 minus 2. That's not 2. We have 2 minus this, which is negative 2. That's 4. And of course, 4 over 4 really does equal 1. So, if your teacher asks you to prove that identity, well, you square cos. You take the definition of cos and you square it. You take the definition of sinh and you square it. And you subtract them. And like magic, you get 1. So that's just a complicated way of writing 1. Now, if you were to divide everything by, say, cosh squared of x, cosh squared of x, cosh squared of x. Well, over here, you get 1 minus. Well, sinh of x divided by cosh of x is hyperbolic tangent of x. But it gets squared. Because this is really sinh of x over cosh of x times sinh of x cosh of x. Sinh squared of x divided by cosh squared of x. Just have to know what squared means. It means multiply by itself 2 times. Multiply by itself 2 times. Cosh x times cosh x. That's tangent x times tangent hyperbolic x. Both of them are hyperbolic tangent of x. So that's what we get. Hyperbolic tangent squared x. And on the right side, 1 over cosh is sinh. But this is really 1 over cosh x times 1 over cosh x. You may say, well, the 1's not being squared. Fair enough. But coincidentally, 1 times 1 is 1. And when I multiply the bottoms, I do get cosh squared x. Each of these is secant hyperbolic of x. So let me write that, excuse me. Secant hyperbolic of x. And there's an identity. Here is an identity. You have this. Of course, if you interchange those two, the 1 stays. The understood positive hyperbolic secant of squared of h, it comes to the left as minus, and the understood minus hyperbolic tangent squared of x goes to the right as positive hyperbolic tangent of x. I mean, here's 2 formulas, but I wouldn't remember both of them. Definitely not in that case. Okay, that's another identity. Know this one, or know the one above. It's going to keep coming up. You must know these identities. Another identity is going to be hyperbolic cotangent squared of x minus hyperbolic cosecant squared of x. This is going to equal to 1, isn't it? That's going to equal to 1. All you do is, instead of dividing this 1 by cosh squared of x, divide it by sinh squared of x. And bingo! This one comes up. Well, I'm getting tired of doing this. Look it up in your book and your textbook. Go online and look up hyperbolic identities, identities of hyperbolic functions, and you'll get all of them. You even have some for inverse. The sinh inverse of x is equal to these, at least the first 2 are definitely going to be natural logs. It's natural log of x plus the square root of x squared plus 1. And since what's in the brackets is always positive, the reason is this is always bigger than the absolute value of x. So when you add x to it, it'll always be positive. Why am I saying that? Because the domain, that is the x values, can be anything. You can put any number there. That wasn't true for cosine. I mean for sine. It had to be between -1 and 1. I meant to say sine inverse. Sine inverse of x, x had to be between plus and minus 1. Now, the Cos inverse of x is also going to be a natural log. In fact, I suspect it's going to be very similar. I guess it would just be a -1 there. Now, that's going to change the domain, I guess. Yeah, it goes from 1 to infinity. Goes from 1 to infinity. And there are 4 others. There's 6 in total. Now, things you should know is the derivative of these hyperbolic inverse functions. Say this one. This is u prime over, see if I remember, yeah, u squared plus 1. And the derivative of hyperbolic cosine inverse of u, derivative of that, well, I haven't done these in a while, but yeah, there's no reason why it wouldn't just be u squared minus 1. The square root of u squared minus 1. Yeah. Okay, and there's 4 others. Look up the derivative of these hyperbolic inverse functions. There's an awful lot to remember in this section. Unfortunately, it doesn't even come up a lot. Well, I guess maybe in engineering it does. Okay, so let's just evaluate some of these things. Evaluate. What is the sinh of 2? Well, you need to remember that the sinh of x is defined in terms of x. It was e to the x minus e to the minus x over 2. Well, if they plug in 2 for x, how about we do the same? We get e squared minus e to the negative 2 over 2. That's the exact value. You don't want negative exponents? Then it'll be e squared minus, this is 1 over e squared over 2. And then I would multiply top and bottom by e squared. So when I multiply this by e squared, I'll just get negative 1. When I multiply e squared by e squared, I'll get e to the 4th. And the bottom, I have 2 times e squared. Okay. Now, the top is a difference of squares. What's being squared here? E squared is being squared. What's being squared here? 1. It's a difference of squares. Write down the things that are being squared, namely e squared and 1. Write them down twice. Put a minus in one bracket and a plus in the other bracket. 2e squared. The bottom is 2e squared. You know what? We can still factor the top. In the first bracket, we have the difference of squares. Here, we have e being squared, and here we have 1 being squared. E and 1. Write them down twice. 1 with the minus, 1 with a plus. E squared plus 1 can't be factored. the sum of squares. E squared plus 1 squared can't be factored. So there's the nicest way of writing that. That's in factored form. I guess if you wrote this, that would be okay. But that's really between you and your teacher, where to stop. Unfortunately, some teachers will just tell you to plug it in a calculator and get an approximate answer. The math class, I want exact answers. Suppose you were asked to calculate the cosecant hyperbolic of ln of 2. Well, that's kind of complicated, which is fine. Cosecant of any hyperbolic cosecant of anything is 1 over the sinh of the anything. Well, this time it's the reciprocal. You have 2 on top. You have e to the x, but that's x. E to the ln of 2 minus e to the minus ln of 2. Now what you have to recall from trigonometry, that e to the ln of anything, well, so long as the anything is positive. Because you can't take ln of 0 or negative. This is just anything. E to the ln of anything is just anything. So that's a 2, of course. Here we have e to the ln of 2. Well, that's 2. Minus, over here, we do not have e to the ln of something. We have e to the minus ln of something. We need to get rid of that minus. E to the minus ln of 2. Well, that's e to the negative 1 ln of 2. But numbers in front of ln's can go up as powers. So you have e to the ln of 2 to the negative 1. Now we have e to the ln of something. It equals that something, which happens to be a half. Okay, so here we're going to get a nice exact answer. The numerator is 2, and if you have 2 and you take away a half, you have 1 1/2, which is 3 halves. Double the top, double the bottom. I'm doubling the bottom to kill off that 2. So the bottom is just 3, and of course 2 times 2 is 4. There's your answer, 4 over 3. And this time we got an exact answer. Well, we got an exact answer that we kind of understood. To get e squared minus e to the negative 2 over 2, that's an exact answer. But if I ask you, is it between 1 and 2, or 2 and 3, or 9 and 10, you probably say, I don't know. But 4/3 is between 1 and 2. It's 1 and 1/3. Okay. What about the hyperbolic cosine inverse of 2? So, what you need to remember is the hyperbolic cosine inverse formula of x. And that, if I remember correctly, that was ln of x plus the square root of x squared minus 1. No, actually, that was a derivative. No, actually, this is correct. And remember, the domain was from 1 to infinity. So I'm not going to plug that number in unless it's between 1 and infinity. And since there's more than 1, 2 is more than 1, it's between 1 and infinity. So this is the rule I use. Except wherever I see x, I plug in 2. Okay, ln of 2 plus the square root of 2 squared minus 1. ln of 2 plus 4 minus 1 is 3. And there's your exact answer. It's ln of that. Remember, this is not ln of 2 plus ln of square root of 3. If you had ln of 2 times the square root of 3, that's ln of 2 plus ln of square root of 3. Okay, so here is your exact answer. Never ever put down what it isn't, say on an exam or something. You know, I would put a check mark there. I would say, yes, this line does not equal that line. And it also doesn't equal to 17.3. Why tell me what it doesn't equal? I'm saying it so you don't try to be slick and try to simplify it. Final answer was ln of 2 plus square root of 3. Just plug in the number into the formula. If somebody asks you what is the hyperbolic tangent inverse, the number is 0. What you need to do is just use the formula for hyperbolic tangent inverse of x. Which I don't know. Let me look up that formula. This is 1/2 ln of 1 plus x. 1 plus x over 1 minus x. And I guess x has to be between minus 1 and 1. Yeah. That would make this positive. Alright, so they're telling me that it's 0. X is 0. So I'm going to get 0. Get 1/2 ln of 1 plus 0, which is 1 of course, over 1 minus 0, which is 1. So I have 1/2 ln of 1 over 1, and 1 over 1, of course, is 1, but that's 0. Ln of 1 is shorthand for log base e, for log base e of 1. And the answer is the answer to this question. E to what power gives me 1? The answer is 0. Ln of 1 is 0. And of course, 1/2 times 0 is 0. I'll say of course because you should know the 0 table. I'll say of course 1 over 1 is 1 because you should know that. Okay, so what does this equal? It equals 0. So somebody asks you on the next problem, what is 2 plus the hyperbolic tan inverse of 0? You should say, oh, that's 2. 2 plus, oh yeah, that was the last problem, that's 0. Yeah, 2 plus 0 is 2. I don't care if something looks hard. If you come to know it's 0, well then it's 0. 2 plus 0 is 2. Never be afraid of that. If something complicated looking is 4, well then 7 plus that complicated looking thing is 7 plus 4, which is 11. Okay. Now, if you're told that y is equal to the sinh of 1 minus x squared, 1 minus x squared, and you're asked to find the derivative, well, you know that the derivative of the sinh of anything is simply the cos of the same anything times, I'll say it in front this time, times the derivative of the anything. Okay, so it's the derivative of the anything, that's u. It's the derivative of u, which is negative 2x, times cosh, whatever that is, of u. And u is 1 minus x squared, and I shouldn't say equals, I should say y prime equals. Because if I don't write y prime here, then you're saying y equals that, and if I was in a bad mood, I'd give you no credit because you never even attempted to tell me what y prime was. Write down what you mean. Y prime equals that. Students really have a hard time doing that. I don't get that at all. So you had y is equal to the cotangent hyperbolic of 3x. Well, you need to know that the derivative of cotangent hyperbolic of anything is negative the cosecant squared hyperbolic of the same angle times in front the derivative. The minus is still there. That is, y prime is the derivative of the angle, which is 3, times negative cosecant hyperbolic squared of 3x. There is your answer. You have to know the formulas. If you know the formulas, you just plug in. Other than having to memorize all of these formulas, all we're doing is taking derivatives of polynomials. What's the derivative of 3x? That wasn't hard. The answer is negative. U is the derivative of u is 3x, the derivative is 3. CSCH squared, and u happen to be 3x. There's the answer. You just plug it in. Just plug in. Plug and go. Go to the next problem. Go to the movies. Don't spend lots of time on these because they're very, very straightforward. And if you're having a hard time, contact me. We'll make these easier for you. If somebody asks you if y is equal to the sinh inverse of the tangent of x, find y prime. Well, you need to know the derivative. You need to know the derivative of hyperbolic tangent inverse. The derivative of a hyperbolic sine, inverse of anything. You need to know what that is. It's going to be u prime over u squared plus 1. That's what it is, right? What's u? Tangent x. It's tangent x, alright? So I get the derivative of tangent x on the top, which is just secant squared x. And on the bottom, I get u squared plus 1. Tangent squared x plus 1. But if you remember, that's secant x. Or it's the square root of secant x. So you have secant squared x over secant x, which is secant x. Okay, so the derivative of this is just secant x. So if somebody were to ask you, what is the hyperbolic inverse of the tangent of pi? Now we're talking about, why do I keep doing this? This is y prime. This is y prime. Y prime equals that. Y prime equals that, not y. ask you to find the derivative of this. Y is equal to cosecant hyperbolic inverse. What's a good angle to use? We'll just use x squared. Here's a function to a power. The first part of the derivative is the old method. Bring down the power, make the new power 1 less. You don't have to denote 1. Times the derivative of hyperbolic cosecant of x. Which is negative x over the absolute value of x times the square root of 1 plus x squared. Why? Because the derivative of cosecant hyperbolic inverse of u was negative u over the absolute value of u times the square root of negative u prime, over the square root of 1 plus u squared. You need to know this. And all you had to do was plug x in. Just plug x. Instead of u, it's x. X prime is 1. Square root of x. X squared. Negative 1 over the absolute value of x times the square root of 1 plus x squared. Times the stuff in the front from the general power rule. That is, here's your whole answer. Okay. Let us try some integrals. Remember, the integral of the sinh of u times du is just the cos of u plus c. So if you were asked to find the integral of the sinh of 2x plus 1 du, well, dx, excuse me. The reason it's dx is because my function is in terms of x. If I let what I just happened to underline du, well then du will be 2dx. To have du, I need 2dx. Now, that's du. But in order to put a 2 in, I have to bring out a half. So now I have 1/2 the integral of the sinh of u. Of the sinh of u times this, which is du. And you say, oh, I know this integral. It's the cos of u plus c. And then just substitute back. Just substitute back what u happen to be. U happens to be 2x plus 1. Well, credit for that answer. It wasn't that hard. You had to know that formula. You just have to know that formula. If you're asked to find the integral of the cos of 3x squared plus 6x plus 2, and you have x plus 1 dx, well, you should always let u equal this, what you're taking the hyperbolic function of, unless this is x or y or z. But if it's more complicated, let it be u. Let u equal 3x squared plus 6x plus 2. Well then du will be 6x plus 6 dx. Well, that doesn't look like this, because I'm reserving this for a cos of u. Well, if you factor out the 6, then it starts to look closer. We have x plus 1 dx, we just don't have the 6. a constant is no big deal. Put in the constant, bring out the reciprocal. And believe it or not, that was a 6. Okay, so this part, that's reserved for du, and that's u. So I'm in the form of 1/6 the integral cosh, hyperbolic cosh, or cosh, excuse me, of u du. Hyperbolic cosh, or cosine of u du. But I know what that integral is. It's the sinh of u. It's the sinh of u plus a constant. And all I have to do is type in what u is. And no random guessing. U equals 3x squared plus 6x plus 2. 3x squared plus 6x plus 2. There's your complete answer. You were asked to find the integral of cosh of x over the sinh of x dx. Well, just let u equal the bottom. The differential of u is u, is du, and differential of sinh of x, well, that's cosh of x times dx. But that's exactly what I have on the top. The top is du, and the bottom is u. I know that answer. That's ln of u plus c. And u is sinh of x. Very straightforward integral. No magic there. If you had the integral of the hyperbolic secant squared of x times hyperbolic tangent of x dx. In the past, I've mentioned that you should always it's generally good or correct to let what's being raised to a power be u. That is, I would generally say let u equal this. And then this piece here would be u squared. The problem is what's left over, namely that stuff, is not du. The derivative or differential of hyperbolic secant of x is hyperbolic secant of x times tangent of x times dx, and that there might be a minus in front. I don't remember, but I do know one thing. It's not this. It's not that. So this didn't work. This didn't work. But you know what? If you let the other piece be u, if you were to let just that be u, if u was hyperbolic tangent of x, well then du would be secant hyperbolic squared of x dx. I must make sure that there's no minus on there. No minus. Okay. But that's what's left over. That's what's left over. That is, this integral so you don't have to write it this way, is hyperbolic tangent, of x times secant hyperbolic squared of x dx. Multiplication surely commutes. This is u, that's du. So we're in the form of u du. Remember, that's u to the 1. So this is just u squared over 2 plus c. Just plug back in what u is. U is hyperbolic tangent of x. Okay? Hyperbolic tangent of x is my answer. Hyperbolic tangent of x squared over 2 plus c. Of course, that power 2 can come after the h. Either one would be acceptable. If somebody asked you, what is the integral of the sinh squared of x dx? Now, I guess you always have this out. You can always say, well, sinh is e to the x minus e to the minus x over 2. That is sinh of x by definition. If I square both sides, I get e to the 2x minus e to the minus 2x plus 2. Yeah. Over 2. That is, we're really just being asked to do integrate e to the 2x minus e to the minus 2x plus 2. In fact, I'll even bring that 2 in the bottom in front. And this is all dx. Now remember, the integral of e to the u du is just e to the u plus c. So this mess is the same as the integral of, well, many integrals. The integral of e to the 2x dx minus the integral of e to the minus 2x dx plus the integral of 2 dx. Now whether you write down the 3 integrals like I did, or you just think 3 integrals, that's fine, but you have to think 3 integrals. Let's do each one. Let's do them on the side. So here's my half. The first integral, e to the 2x. Well, if I call that u, then du would be 2 dx. That's du. So I have to bring out a half. So I'm in the form 1/2 the integral of u du. But that's an easy one. Integral of u du is u squared over 2. That is, I'm going to have u squared over 4. And when you... Okay, I take that back. I'm so sorry. It's e to the u. This here is e to the u. And the integral of e to the u du is just e to the u. That is, it's e to the 2x with a half in front. Say e to the 2x over 2. So it's e to the 2x over 2 minus this integral. The big difference is the exponent is not 2, but rather minus 2, or negative 2. So the derivative of negative 2x would be, if u equals negative 2x, then du would be negative 2 dx. So I'd have to factor out a minus a half. Okay, and then I get the same thing. This here would be e to the u du. The integral of e to the u du is just e to the u. So it would be minus a half times e to the u, or negative e to the u over 2. This here is the same as negative 1 times e to the u, which is negative e to the u over the 2. And the exponent is u is negative 2x. So I have minus, which makes this plus, e to the negative 2x over 2, plus the integral of 2 dx is just 2x. And there's an answer. There's a nice answer. Plus c, I guess. So this here is the answer, so long as you include plus c. Now, there was another way to do that problem. There was another way to do the problem. And it would be easier. So usually, to make things easier, you have to pay a price. Like when you do a u substitution, you get an easier problem, but you had to do the u substitution. Here, if you knew that the sine squared of x would equal to, and to be honest, I didn't know this, that it equals to negative 1 something's wrong there. Negative 1 plus hyperbolic cos of 2x over 2. So this is the same as the integral of negative 1 plus hyperbolic cos of 2x over 2. The over 2 I'll bring in front. That's what this is. Times dx. Times dx. So this is 1/2 times the integral of negative 1 dx, integral of this dx, plus the integral of this dx. And the first integral, I hope, is easy. It's just negative 1. Times, excuse me, it's negative x if I say negative 1. Plus this integral, and of course I have a typo, it's hyperbolic cosine of 2x. dx. Let's do this one on the side. Well, we know that the hyperbolic cosine of u, du, is hyperbolic sine of u plus c. We know that. Well, we have the cos of 2x dx. That's u. That's u. If u is 2x, well then du is 2 dx. So we have to add stuff. If I multiply by 2, here is my 2 dx. But to do that, I have to bring a half in front. So I get 1/2 the integral of the cos of u du. But I know what that is. That's 1/2 the sinh of u plus c. And u was 2x. I know it is. It told me. So I get 1/2. That is, this integral is 1/2 the hyperbolic sine, or the sinh, of 2x plus c. And hopefully this is the same answer I got before. Well, it's going to look different because in the problem before, I didn't have any hyperbolic functions. That is, I converted things like this to e to the 2x minus e to the minus 2x all over 2. So, to make it look like what I got before, it should be this. And if I didn't get this, either they're equivalent or I made a silly mistake. The big difference is I have the half in front, like I have now, but in the last problem, in the green box, I have plus 2x, and here I have minus x. I'm not sure what happened. Let me see if I can figure out what could have happened. Could have made a mistake on the last one. Okay, well, one of them has a mistake. Go and find it. I will say this last problem has a very, very minor error. The very last line, it should say plus e. Plus e. Do not do every integral right, say 10 for 10, and then end up getting a 90 because the teacher took off 1 point on each integral because you didn't write plus e. Okay, let's try some of these harder looking integrals. Suppose you have dx over x minus 1, x minus 1 times x squared minus 2x plus 2 square root. Suppose you have this integral. First thing I do is I will complete the square on that. X squared minus 2x plus 2. Isolate that. X squared minus 2x plus 2. Well, if you take half of that number, we're going to complete the square. You take half of that number and square it. And half of that number we need to have. It's negative 1. And we square it and we get 1. So I add 1, well then I better take away 1. Now what's in those brackets is now something squared. It's x followed by half of this number, which is right there, negative 1, plus 2 minus 1 is plus 1. So this becomes the integral of dx over x minus 1 times the square root of x minus 1 squared plus 1. Now I'll say, you know what, I'm just going to call that u. If I let u be x minus 1, then du just becomes a dx. Okay. So the top dx, well that's just du, and I said that's u, and there it is again. But that's u squared plus 1 underneath the square root sign. Okay. So you have that integral. Now, in this problem, we can use trig substitution like we did in the last section. Or we could remember those integral forms. You could remember that the integral of du over u times u squared plus or minus 1. Actually, plus or minus a squared. this is equal to 1 over a. This one I have to copy. This is 1 over a. In our case, a is 1. 1 over a times the ln of a plus the square root of a squared plus or minus u squared over the absolute value of u, it's ln of that, plus c. Now, let me talk about this plus or minus. If you're going to read the minus, that is, if you want to know what's the integral of du over u times the square root of u squared minus a squared, if you're going to read not the minus but the bottom sign, which happens to be minus, anytime you have two signs, you have to read the bottom one. If you want to read the top one, which in our case we do because it's plus, then we're going to read the plus answer. Now all you have to do is decide what a and u are. You know what u is, it's x minus 1, and a is 1. You have to realize that a is 1. And you also have to realize that I made a big mistake by erasing what I just did. So you have du over u times the square root of u squared is first. I guess it would matter. Now this is a squared plus or minus u squared. This is 1 over a times ln of a times the square root, a plus the square root of a squared plus or minus u squared, all over the absolute value of u. Okay, so we have this. This is exactly what we have. We have the plus, and a is 1. So I get 1 over 1, which is 1, I won't write it, times ln of a, which is 1, plus the square root of 1 squared, which is 1. We're going to read the plus because that's what our integral has. Our integral has the plus. Let me say it again. Since our integral has the plus, we're going to read the plus here, which is the top symbol. It is possible that maybe you'll have a plus or minus b squared. This is a squared minus or plus b squared. If that were true, then if you read the plus here, on the right side you'd have to read the minus. If you read the bottom one, then you always have to read the bottom one. Except that equal sign is not true. But if it were, if you read the top symbol, you have to always read the top symbol. Okay, so it's plus u squared. Well, u was x minus 1. It says so right there. Divided by the absolute value of u, plus c. And there's your answer. There's your answer. You could have done trig substitution like we did in the last section. Let's try one more of these. And you have to recognize what form it fits in. Suppose you have the integral of 1 over 1 minus 4x minus 2x squared minus 2x squared 1 times dx. Well, negative 2x squared minus 4x plus 1 is equal to negative 2x squared plus 4x minus 1. Now, I'm going to keep that minus there and pretty much ignore it. You have 2x squared plus 4x, and you're going to take away the 1. You can factor out a 2 from here. You have 2 times x squared plus 2x. Now, what you write here is half of that number. Half of 2 is 1. When you square it, you get 1. But you didn't just add 1. If anything, you added 2. So you always had minus 1, and now you have to take away 2 to balance it out. So you have negative 2 times, now what's in the bracket is x followed by half of 2, which is positive 1 squared minus 3. Distributing that minus in front, that gives you 3 minus 2 times x plus 1 squared. The thing is, I don't like that 2 in front. I don't like that 2. I'm going to factor out the 2. Then I get 3 over 2 minus x plus 1 squared. 2 times 3 over 2 is 3. You have to be able to factor out a 3. I meant to say a 2. Okay, so now we get dx on the top, and in the bottom we have this. We have 2 times 3 over 2 minus x plus 1 squared. The integral of that. Okay. What we've done so far is just pretty much side work. It's completing the square. Let's get rid of it. That 2, I'm going to factor out. The 2 in the bottom. So it's really 1/2 the integral of dx over 3 over 2 minus x plus 1 squared. Now, if that's a squared, if a squared is 3 over 2, then a is the square root of 3 over 2. Plus or minus, but we'll say plus. And that's u. And u is x plus 1. That is, we are in the form of 1/2. Oh, if that's u, well then du is dx. This is du. Dx is du. In the bottom, we have a squared minus u squared. And this is going to fit into one of our formulas exactly. Whenever you have this integral, whenever you have the integral of du over a squared minus u squared, you always get 1 over 2 times a times the ln of the absolute value of a plus u divided by a minus u plus c. I'm getting these formulas right from the section entitled Hyperbolic Functions. So actually that's what I get. Okay, I get the half times this. 1 over 2a ln of a plus u over a minus u plus c. Now all I have to do is plug in a and u. So this is 1 over 4a. It's 1 over 4 times a, where a is the square root of 3 over 2, times ln of the absolute value of a, which is square root of 3 over 2, plus u, which is x plus 1, divided by a minus x plus 1 plus c. Okay, let's just clean up some stuff. Let's clean up this. We have 1 over 4 times the square root of 3 over the square root of 2. This square root of 2 can go on top. That is, we have the square root of 2 times 4 square root of 3. Oh, let's multiply the top by square root of 3 and the bottom by square root of 3. So now the top is the square root of 2 times 3, or 6. And square root of 3 times square root of 3 is 3, times 4 is 12. Okay, so equals over here the square root of 6 over 12. The square root of 6 over 12 times ln. You know what, I'm just going to leave the rest the same. What I will say is this here. The square root of 3 over the square root of 2 is the square root of 6 over 2. This ln of the square root of 6 over 2 plus x plus 1 divided by the square root of 6 over 2 minus, I'll distribute the minus, minus x minus 1. I take away x and I take away 1 plus c. You want to multiply top. Actually, now that there's no more square roots, why don't we do that? Let us multiply the top and the bottom in the very final answer in the absolute value bars by 2. Let's just multiply top and bottom by 2. And multiply each of these on the top by 2, and then the same in the bottom. We have the square root of 6 over 12 times ln of, when I multiply that by 2, I get square root of 6. When I multiply that by 2, I get plus 2x. When I multiply 1 by 2, I get plus 2. And I get a similar thing in the bottom. I get square root of 6 minus 2x minus 2 plus c. There's that answer, and there's the section. Very, very long section.